Yeah, so yeah, I'm Andrew Brydon, formerly worked for NAB. I used to run the application platform engineering team there. I was there for about 6 years. I've got 20 plus years in technology. I'm going to use 20 plus. We won't have an exact number. But 10 of those is in banking. Also several years in consulting. So I've got a heavy focus on DevOps, DevSecOps over the years. I'm very involved in the automation of the process of engineering in a bank, and how do you improve it and optimize it, and take learnings and plow those back into improving things. So yeah, I'm going to talk from the context of NAB, which is the second largest business bank in Australia, about 140 years old, and all of the legacy that goes along with that. So you can imagine the oldest application in the bank that's still running is from 1967, written in assembler on the mainframe. So dealing with that all the way through to modern microservices running on Kubernetes. So every type of legacy complexity you can think of, an integration you can think of, we had to work with it and work out how to make that more efficient for our software developers to use. So I'm going to talk a little bit about just industry challenges, because we all face kind of the same things, I think, across whichever area we work in. Maybe some stuff is a bit more FSI related, and then some key things that I think we need to think about. I'll try and boil it down to a couple of things to focus on, because otherwise there's too much kind of context for the brain to handle. And I'll kind of start off with the challenges. So we've had in Australia some quite notable breaches, particularly in health insurance, and in 2 weeks ago in our national airline. I got a lovely email from our airline saying that this is all the data that we've lost that belonged to you, and it was pretty much everything except for my credit card number. So that's the world we live in. So, but as an organization, how do we protect our customer data? And that's the kind of key thing we have to think about. How do we ensure that the developers working in our environment are optimized to protect customer data? We're not putting them in a position where they can risk exposing that. So these things are kind of key things to think about. We have to deal with a lot of legacy. We have mainframes. We have 3-tier apps. We use SAP. We use lots of other big systems that are not necessarily written by ourselves, but they're things that run our organizations, and we have to make sure we can work with them. How do we scale for peak loads? We were talking about this at the table earlier about people looking up at specific days of the year, looking up balances on their accounts and causing scaling issues in organizations. How do we support that? And then finally, one of the things I'd spent a lot of time on recently was the developer productivity aspect. So I think this number here is understated. 30% of development time is spent on non-development work. I actually think it's more like 50%. It's quite an interesting thing to look into, and I'll kind of dig into that more in a bit. So we've all been moving to cloud. Kind of everyone here has to be on some part of that journey. And what I think is interesting is that a lot of organizations have had a cloud-first strategy, and that seems to be kind of softening a bit over time. My organization was very much about being cloud-first. So we used AWS, we used Azure. We used AWS for a long time, and then we decided to add Azure to make multi-cloud. We were talking about multi-cloud before. My definition of multi-cloud is an application can run on both clouds. And I think that's kind of what we're talking about. That's a complex thing to engineer. And you kind of have to change your expectations sometimes around your applications. And can they run on 2 clouds? How do you get data between 2 clouds? It's an incredibly complex thing to do. really means that you either have to synchronize data between two sets of different types of infrastructure, or you're doing backups and restores, and you get a much longer time to get an application back up and running on a second cloud. We're probably facing into a lot of scenarios where, and we were talking about this on the table as well before, where teams want to use ClickOps over using infrastructure as code in a repeatable way. And I think that leads to a lot of lack of standardization. The key thing when you're working in FSI is that lack of standardization is actually a security risk, and you also can't, it's hard to understand where your configuration risks are, report them, and remediate them. And I feel like that organizations get very excited about moving to cloud. They get a significant proportion of apps into cloud, and they realize that it actually gets hard. And it is hard, and the trick is, how do you keep going? There is a statistic that says that the average transformation takes around 8 years. That's a long time. And you have to keep going, so it's a marathon, not a sprint. Now, in my former company, we ran 2,500 applications across, initially in the data center, and we moved 90% of those into the cloud. But we saw things like mainframe as taking another maybe 10 years. So data center was going to be around still for us for a long time. Excuse me. So we have to keep thinking about these things. And then the other thing we had to deal with as an organization was when we wanted to go to cloud was a skills gap. We'd been heavily outsourced. We didn't actually have cloud skills at the time. So we used going to cloud as a mechanism to hire a whole bunch of engineers into the organization and really create momentum around it. Actually created other challenges as well, because it meant that each team, we had about 200 teams in the bank, was implementing cloud differently. We would give them a landing zone, and then it would be up to them how they deployed their apps. So it created inconsistency even within those cloud environments. And I think the last important thing is, by doing that, we actually allowed too many kind of exceptions to architecture and enterprise architecture to occur, and it's kind of hard to maintain. We didn't have any kind of consistent standards. So keep going with your cloud migrations. Keep thinking about standardizing. I cannot kind of urge you to standardize early enough. It will save you so much time later, especially as you scale your cloud migrations. So there has to be some benefits to all of this, right? We're doing it for a reason. I think initially it's quite easy to start that journey. At some point, the financial and business side of your organization is going to want to understand what the benefits are. We took the opportunity actually to create a full business case for cloud migration and insourcing our teams at the beginning of when we started doing the work. So when the conversation kept coming up around what the benefits were, each year we went through and refreshed that business case to track the benefits. But it was something that we could keep going back to our business with to kind of show that going to cloud was benefiting the organization, and a lot more than they realized. So I got some more kind of technical benefits here, but really I think getting our data secure was a key one. Getting business change out faster is always another key benefit. Resiliency. We went from having thousands of infrastructure incidents a year to zero. Like zero for the applications we went to cloud. I think AWS has had 2 or 3 incidents in the last 5 years on their platform, and it's not affected the whole platform, it's only affected part of it. You never have that problem in the data center. It'd always be exacerbated. So we're in the cloud. We'd moved lots of applications there. We were doing a lot more in-house development ourselves. We started speaking to the cloud providers on actually how they do software development. So they talked to us about consistent centralized pipelines for deploying software into the cloud, which had no human interaction. And that was a model that we aspired to. We came up with something we called the NAB Engineering Foundation at the time, and that was a kind of standard template for deploying software. Actually created another problem. It became too easy to deploy new microservices in the organization. We ended up, I think we exploded out to 6,000 APIs at some point. So, you remove a bottleneck here, you create another problem over here. So all the time we were changing things, learning, but we still hadn't reached a point, kind of a good state in terms of how we were managing our software that was consistent. So we focused on, as I said, we kind of narrowed down and focused on kind of two key things. How do we think abstracting all the elements around compliance and security for our engineers? And how do we focus on improving their productivity? So I'm talking about software, I'm talking about engineers, I'm talking about software engineers. So they're writing customer-facing software. We wanted to really, as I said, abstract everything around the deployment and management of infrastructure and deployment of software into production from the engineers. So they just check code into production, into GitHub, and it is deployed into production, or having gone through the various testing cycles. So that actually required us to change a few things and understand some things as well. Now, does anyone actually measure the productivity of their engineers at all? Like, we always make assumptions around some of the statistics. Have you ever put in any tools to do it? It's a really interesting exercise. So we put a tool in that sits on top of GitHub and actually measures how much time engineers spend writing code. And this is the statistic that's up here, 2.5 days a week. So that's across 4,000 engineers. So we had two choices. We optimize within the 2.5 days to make them faster, or we try and increase the 2.5 days to 3, right? Half a day across 4,000 engineers is worth about, in the bank was worth about $100 million of productivity a year. So it's a big number. But you have to actually understand this, have the data to back it up. Because that's a really easy business case to have. With a business team or any team, your superiors, it's kind of, actually usually that number is a number they don't believe, especially if you've dealt with any finance team. They will say it's BS. But no, this is absolutely true. So what that number represents is the time spent an engineer coding and checking code into GitHub, and there's a whole bunch of data that sits behind it. So this is where we came to the conclusion that we needed to create a central team to manage that whole abstraction layer and create a standard platform for application management and delivery. So we had to really kind of change our organization, change the way we manage cloud, change the way we manage cloud and abstract it from our engineers. Now this works for in-house developed applications. They're probably thinking, what about our three-tier apps that we buy from our vendors? Well, I will cover that off. It's not as simple, but you can definitely apply a lot of the same kind of logic into it that I'm going to discuss to that. So we started thinking about our operating model. How do we use GitHub better to manage code? How do we put more restrictions around what teams can do? How do we bring our security friends and colleagues into our team to manage with us? And how do we support our divisional organization? So we set up a team that looks like this. So our central DevSecOps team, so they manage all the software tools that a team needs to develop with. GitHub, Artifactory, thank you. Thank you very much. I'm a quiet person. I'm not used to talking this much, so just laughing over there. It's true. So we created a central DevSecOps team. Their job was to provide CI/CD templates for teams that each team can use for their applications that can't be changed. They're immutable. And that's and set up the teams so they check their code into GitHub, and they get deployed into various environments for testing and then go into production. So that's their role. The second part of their role is to migrate all of NAB's managed apps, in-house developed apps, onto this platform. So that's about 1,000 applications. So it's not a small number, just around 40%. The other thing we had to come up with is a plan to get this work done. So in thinking about the 8 years to do, transformation end to end, this is probably about 2 to 3 years worth of work to do all the applications. So, but this is when you're getting towards the tail end of the transformation. Although it's never done, I'm told. Like you're always on the next transformation, especially when it comes to AI. So we put in new tooling, SAS, a single CI/CD tool, which allowed us to have full observability of deployments, understand failures, integrate with all the other tooling that we had, and also allowed us to enforce things like canary deployments, automated rollbacks, all that kind of thing. And this is how you get consistent and faster. Now, what's interesting is if you look at, once you have that data, you can see how often teams are actually deploying. It's kind of eye-opening. Teams will tell you that they're deploying all the time, that every day they're doing. It's not true. It's just not true. I reckon we were seeing the fastest teams doing a deployment every 2 weeks. And then there's some crazy things going on. Like we had a team doing 500 builds a day, but deploying every month. And actually, they were chewing up the most resources on the platform. But because we have that observability, then we could go and have a conversation with them about what are your dev practices. They're literally doing a build every time someone checked in any code. So that could be one minor change, like they change a word, and it would do a build. So it's kind of interesting once you start seeing the data and it starts to flow through. So here we've got a kind of overview of the tech behind it. So on the development side, we started standardizing all our engineering practices onto basically 2 IDEs. So you either use IntelliJ or VS Code. That actually allowed us to start bringing in developer AI tools because we did standardize on these things very easily, and gave us a kind of common way to deploy a developer experience when they join the organization. We used, and I actually think GitHub is one of the most powerful tools you have in an organization to control and manage how software development works. We enforce branch protection. We scan and block secrets from going into GitHub. We have Vault as well in the environment, which will be integrated here with once it's up and running. With I didn't have time to do that when I was there, but to do scanning for secrets, and then produce an artifact that goes into Artifactory that's then pushed with infrastructure via Terraform into the various environments. So then we're in continuous integration. So we're using a SAS-based CI/CD tool, enforced security steps. So who's worked with some of the security tools and seen how long they can add to a build. I think build times initially were 45 minutes. We had to work with our security teams to actually went through swabbing out tools. So we went to Snyk and Wiz to really reduce those build times with a goal of getting down to 2 minutes. I think we got it down to about 10 minutes before I left. It's actually too long because if a developer is working on something and they have to step away for 10 minutes, the context of what they're doing is gone. They have to come back and like re-engage with it. So you kind of want to get that build time down under a minute if you can. And then we deploy via the artifact deployment into a Kubernetes cluster in production. We actually ran, this is heavily AWS based. We did have a multi-cloud deployment as well, so we had AWS and Azure available for teams to use. Azure, for this type of deployment, was quite underutilized compared to AWS. So I think we had like 900 apps in AWS and 100 in Azure. I think Azure is probably not quite ready for this type of application, and it's more suited to server-based deployments. That's my opinion. So I touched on like how do you kind of implement this and timings, and I did want to cover that off. So when you decide to go down this path, you need to set some engineering standards, and I actually worked heavily with the architecture team at the time. Set engineering standards. Be opinionated about languages you're going to use. It's going to be a very big debate in your organization around languages. That's okay. But you do need to make up your minds and settle on something. We actually went to the point where we ran a 1,500 person webinar with the engineers in the bank, and we just had it out. And there was a lot of disagreement, but we ended up landing on a front end and back end choice, and we shifted everyone to developing on those languages. And we made it to other people have talked about the golden path, made it really easy to deploy those languages into production because those are the only templates that you could use. Now, I did promise, I think it was promised talking about AI. One of the things I did have the opportunity to work with was around AI for code development. I'm kind of curious as well, I have another question. Who thinks that they've got, with AI, they'll be able to get through all the backlog that they have from the business? Like, do you think you'll be able to deliver it all in a year if you have it? 2 years? We had a backlog of 3 years worth of software from our business to deliver. So having AI in our environment to improve productivity by even 10% was not going to make a dent in it. So I don't think there's any issue around using AI and it going to impact the number of software developers you have. It's just going to increase the amount of software that you're going to produce. It actually puts more emphasis on having a platform for software delivery to get that software out into production. So we started testing out with AWS. It was called Code Whisper at the time. It's now called Amazon Q for developer. We tested out. We had a bit of a disaster because someone thought it was a great idea to send our whole executive team out to the US to talk to some organizations around these tools. And there was numbers thrown around about 60% productivity. And so our senior execs thought this was great. We're going to have 60% more code produced by our engineering teams, and we're going to get through all our backlogs, and we had to do a reset on that. And that was an interesting exercise. So we actually had to do another database analysis on productivity. I say it was, and it has been a little while since I looked at it, it's more in the 15 to 20% range. I think that's a reasonable number to use. Now, I think where the interesting thing comes in is around automated testing. This is where you actually see time increases. So writing code and producing automated tests is fantastic. So that means you get much better code coverage. I'm always kind of curious on what people think their code coverage is for testing, because I've seen teams claim it's 80% when it's more like 40%. I think this is the automated testing coverage is one of the key things in this. We even started looking at how do you start having AI create user stories, etc., for your software delivery, and I think this is kind of another kind of interesting area where AI is going to start to feed into the overall kind of delivery mechanism to help engineers create things faster. But all of this is about stopping your engineers from having to do stuff that's not related to software engineering and have them focus on writing code. I think I probably touched on the benefits as well. Faster development life cycles, I think, is a key one, and code quality. I think being able to take code that people write and have it have better quality straight out the door is one of the kind of key things to fix early. You know, if you think about the testing pyramid, if you're familiar with it, the earlier you get things done, faster it is. I think if you're not testing these tools or you're not using them, you should definitely look at them. They're very useful. I mentioned this before, and I think this is the key thing to think about. And this was actually the language we started using internally. Was initially with that 60% number I talked about earlier, it was the business immediately thought we'll need 60% less engineers. We actually changed that conversation around to we're going to create 60% more, or well, actually 20% more kind of creative hours for our engineers in a year. So I think when we think about all of that journey that the organization has gone on, a lot of it is around transforming experiences for customers. And I think that's the key thing to focus back on. You're doing this to improve the products that you have that are customer facing, make them easier to use, and get features out to those customers faster. And that is end to end, from whether it's digital facing through to the infrastructure that we manage. So we make infrastructure provisioning easier, faster, and more scalable, and respond to issues, then we reduce the impact on customers. Security, I think, is paramount in terms of moving to a platform approach, because your security and compliance is baked in at the platform layer. And again, I don't know about in your organizations, but in our organization, access to security architecture was incredibly hard. There is now 3 million open security roles globally. So it just tells me that's going to get harder. So we had this was great for our security teams because they got to approve the platform once, and anyone who used the platform was automatically security approved. So that kind of changed the game for them. And I also had security teams embedded in my team to help this process be smoother. And last, of course, is the productivity element. So teams have standard ways to deploy an app that's templated. It's automated and deployed on a standard set of infrastructure. And this is the kind of key thing here. All infrastructures use standard modules. We control compliance of those via TFE. And they really have to not think about what infrastructure needs to look like in the environment. So in summary, that's a kind of overview of my experiences. I think I've only got 1 minute, so probably no time for questions. But thank you very much. And yeah, happy to take any questions after. All right.